Hello, I'm Steve Buchko, Solace's VP of Product Management for Core Products. Today, I'd like to put the spotlight on the latest version of MQTT, MQTT version 5.0. MQTT 5 is the latest in the open interfaces and protocols that we support on the PubSub Plus event broker. Our CTO team and our architects were heavily involved in defining and standardizing MQTT 5, but it's by no means the only open protocol that's available on the event brokers. So we support the earlier MQTT 3.1, we support JMS and JCA along with Spring Cloud Stream and Spring Boot for Java applications. We have REST and webhooks for your RESTful applications, AMQP 1.0, as well as a rich suite of Solace APIs. And what this really means is that you can mix and match and pick the right API for the job or the problem that you're trying to solve. So if you're building an IoT device, you might want to use MQTT 5. If you're building a back-end server application for that IoT application, you might choose to do that in Java with JMS or Spring Boot. And then if you're building a mobile app that connects into the whole solution, you might choose to do that in JavaScript. And the great thing about the PubSub Plus event broker is that you can bring all these technologies together and interoperate and exchange messages between all these different protocols and all these different interfaces. Now, before we dive into details of MQTT 5.0, it's probably worth taking a step back and answering the question, what is MQTT? So MQTT is a standard defined by Oasis, and it's a publish-subscribe protocol that is meant for the Internet of Things. And it really has become the standard for IoT messaging. It's extremely lightweight, and that means it's very nice for small devices that might have limited RAM, limited CPU. And as a result of that, it's really been adopted by a wide variety of industries. You'll find it in connected cars, you'll find it in smart cities, you'll find it in industrial IoT and manufacturing use cases, and a whole bunch of other things as well. MQTT 3.1 was the first version of MQTT that really achieved widespread adoption. So it was standardized back in late 2014, and it's the version that you'll find in most IoT devices today. Solace has supported it for close to 6 years now, and we've got customers using it for connected cars, smart cities, industrial IoT, shipping and logistics, just to name a few of the use cases. It really is a lightweight protocol, as I mentioned, which makes it ideal for things that have limited CPU and limited RAM. And it supports a basic publish-subscribe paradigm. It has two classes of service you can use. So it has persistent messages, which means even if the client that the message is intended for is offline, the brokers will keep it around until the client comes back, and then the message can get delivered. As well as non-persistent delivery, which is kind of fire and forget. If the consumer is there, the client will get the message. If they're offline, the message gets thrown away. It does also have a couple cool bells and whistles. There's a concept of message retain. So when a publisher publishes a message, you can set a retain flag, and that'll tell the broker, keep the last copy of the message that you see on this topic. So especially useful along with non-persistent delivery, so that when new subscribers come online, they can get the last message that was sent on the topic. MQTT 3.11 also had will messages, and that was a message that a client would send to the broker when it connected, and would tell the broker, if I unexpectedly get disconnected, send out this message so that the other apps connected to the broker will know that I've gone away. Now, as I mentioned on the previous slide, 3.1 really is great for simple devices that need basic PubSub. And as well, the open source APIs had a very strong and vibrant developer community and really helped to drive adoption. And it was a very straightforward spec, really clear spec to implement to. So that meant you could, pick up an open source API if you're building an app running on a standard server or a standard processor. But if your thing had custom hardware, it was pretty easy to write your own API that would run on that custom hardware. And I think that was really one of the strong parts of 3.1, was that the spec was clear enough that you could write an API and you connect to anyone's broker and be pretty sure that your thing would be able to talk to the broker. But to some extent, the simplicity of the specification made things harder for developers, especially if you wanted to use it for server-side applications. Some of the features that are regularly looked for on the server side weren't there. But even on the device side, developers would often find themselves going through hoops and having to do things in a little bit more awkward a way than perhaps a more powerful protocol might have let them to do. And so MQTT 5.0 tries to address some of those gaps. We still want to keep the simplicity, still want to keep the clear specification, but just add a few more capabilities that will make it easier to build powerful apps on the things, as well as adding in some of those things that means that it goes beyond a protocol that sits on the edge of your network, on the devices, and it's something that you can actually use on your server-side apps as well. So a lot of features to help both the developers as well as to expand the scope and the kinds of applications that you can build with the protocol. As a developer or as an architect, you might be wondering, well, when should I be using MQTT 5.0? And I think the first and most obvious use case is for all the IoT use cases we've been talking about earlier, right? So things like smart cities and smart homes and sensor networks, industrial IoT, connected vehicles. MQTT 5.0 brings all the small footprint and ease of use of MQTT 3.1.1. So it's the obvious choice if you're building IoT devices. But mobile apps are another interesting use case as well, because mobile phones, certainly compared to a server, have limited CPU, limited RAM. So a lightweight protocol like MQTT 5 really fits into use cases like that as well. So it's certainly something you should think about if you're building a mobile app. But with some of the new features that have been added with MQTT 5.0, it kind of goes beyond IoT devices and mobile apps. And it really does have enough capability that if you're building server-side applications, if you're building microservices, and you don't necessarily need all the capabilities of a full-fledged messaging API, you should really give MQTT 5 a look, right? And especially if it's an IoT use case that's greenfield, where you're building both the device side and the server side, there is a certain elegance, there's a certain simplicity of being able to use the same protocol end to end. And MQTT 5 makes it easier for you to do that. It adds some of those things that were needed on the server side to make that a much more palatable option than it might have been with MQTT 3.1.1. The other case where MQTT 5 you might find that you need it is that if you're interacting with third parties that you don't have control over, right? So you may not be developing the devices that are connecting to your applications, or you might not be building the apps that your devices want to connect to. And those things might be speaking MQTT 5. So in those cases, you're also going to want to use, of course, MQTT version 5. The thing you might then be wondering is, well, when should I use MQTT 5? And when should I use a native Solace API for building my application, right? And I think it's a trade-off of what capabilities do you want in the API versus how portable do you want your application to be. So especially when you're building the server-side applications, depending what you're trying to do, you may need access to more capabilities than MQTT 5 allows you to do. So MQTT 5 has certainly added a lot of things that make it easier to build a server-side application, but there's still a bunch of things in the toolbox that aren't there, right? So if you want to build or interact with a JMS application, there is no JMS API for MQTT. So you'll want to use a Solace JMS API for that. Or if you need message selectors. If you want to do transacted sessions on your server side, right, be it session-based or distributed transactions, that's a case, again, where you want to bring a Solace API into the solution. Or if you want to take advantage of some of the features in the broker that simply we can't expose through MQTT, right? So we have the ability to, in the PubSub Plus event broker, to do message replay, where even after you've delivered and acknowledged a persistent message, we keep it in a replay log So an application can come along later on and ask to replay those messages that it's already received. So if you're using MQTT 5, you can do that through the management interface. You'll be able to go into the management interface on the broker and initiate a replay. But if you want to do it from the apps, you need a Solace API to do that. Solace also has PubSub plus cache. It's similar in some ways to MQTT Retain, but it's a lot more powerful. It's a lot more scalable. So if you need the full capabilities of PubSub plus cache, then you'll need a Solace API to get at the data that's in the PubSub plus cache. If you're building applications that use Solace structured data types in your payload, so that's something that, again, that is something that is only in the native Solace APIs. As well, there's extra metadata that a Solace broker can send to the applications. Things like message delivery account that tell you this is the first, this is second, this is the fourth time I've tried to send the message to you. So things like that, once again, aren't part of the MQTT standard. So it really is a question of what am I trying to do with this application? What capabilities am I going to need? And then picking and choosing the API that works best for the use case. And as I mentioned, the good news is you don't have to use the same API everywhere. It's nice if you can, it makes things easier. But if you're trying to connect, simple devices on limited hardware to some pretty complicated back-end applications, then using MQTT 5 for your devices and the Solace JMS API for your server-side apps, it's a great combination and they work great together. So take a look at your app, see what you want to do, and pick the right API for what you're trying to achieve. Now you might be thinking, well, MQTT 5 sounds pretty good, but I've got thousands of apps deployed that are already using MQTT 3.1. So what am I going to do about those? And the good news is you don't have to do anything. If those apps and those devices are doing what you need, keep them on 3.1. There's no need for you to rush to upgrade those things to MQTT 5.0. Both protocols are supported by the Solace brokers, and you don't need anything special to support both at the same time. So it's not like you have to turn on MQTT 3.1 in client profile or turn on MQTT 5. It's both. They're both there, and the APIs and the broker will handshake and decide which protocol version to use. And you can send messages between the two versions, send messages to other Solace APIs, send messages to AMQP. It all interoperates to the PubSub Plus broker. Now, of course, if you've got an MQTT 5 client and it's taking advantage of some of those extra features that you have, they won't be available to your 3.1 apps. So you have to watch out for that a little bit when you're building new 5.0 apps. But the arrival of MQTT 5 doesn't obsolete what you might already have deployed. And often when it's out in devices, you don't have any way of upgrading them. So once the firmware has shipped, it's going to be on 3.1 for the lifetime of the device. So we recognize that, and that's why the interoperability between 3.1 and 5 is so important. And if you're using open source client APIs, just about all of them already support both 3.1 and 5.0. Those that don't, it's on the roadmap for them to support it. So your client APIs as well will support both versions of MQTT. A question I sometimes get asked is, how real is this IoT thing, right? Like, why should I care about MQTT 5? And the answer is, Internet of Things is very real, right? So we're well beyond, if you look at the, standard hype cycle, we're well beyond the early adopters, the exciting new technology. Now, this is stuff that has been deployed, is in production in a large number of use cases around the world. So this is a slide from Gartner that shows where they view IoT in the hype cycle, and we're very much well beyond basic IoT platforms and into the IoT integration, and very much in the stages where people are doing useful and productive things with IoT platforms. And the number of devices, the number of things using IoT and hence using MQTT just continues to grow at an exponential rate. I thought it would be interesting to take a look at a connected car solution and how MQTT 5 helps you to build a better, more flexible solution than you maybe could have with MQTT 3.1. So over here, we've got a typical IoT connected platform, and this kind of shows the message flow through the connected platform. You've got connected cars that send messages up into the application tier, and then you've got mobile apps that will send messages into the application tier. So basically, the car owners can monitor and control their cars through the mobile app, but they generally don't connect directly. They'll connect through applications that sit in the either in cloud services or in the data centers of the car manufacturers. Now, what this looks like from an event mesh and a messaging viewpoint, you've got the Solace Pub Sub Plus brokers or mesh of brokers. All the cars are connecting into the event mesh using MQTT. And then the applications, the backend applications, they could be using a variety of different APIs. So some of them could be using MQTT. Others might be using JMS. Maybe we've got some others that are using .NET. Meanwhile, the mobile app developers decided to use JavaScript for the mobile apps. And so that's how the application is all tied together and built. Let's look at some of the MQTT 5 features then and how it helps you build a better connected car application. So one of the things that comes with MQTT 5 is some more powerful options for actually building your messages. One of the features it has is the ability to include tagging of the content type and the payload format of any messages that get sent. So a car could be sending different types of data. It could be sending like cabin temperature and various engine sensors and monitors as JSON payload or JSON messages. But if someone gets too close to the car while it's parked, the car might take a picture and then send that as a JPEG. And with content type and payload format, the app in the car can actually tag each message with what kind of data is in the message. And that just makes it easier for the backend service. With MQTT 3.1, there wasn't an easy way to do that. You kind of had to encode that, and kind of any of these special extra things, you had to encode it in the payload of the message. The other really powerful thing is that MQTT 5 adds user properties. So this is extra metadata that you can attach to any MQTT 5 message you send. So in the case of the car, you might be wanting to send things like the vehicle identification number or the firmware version, right? So the VIN number lets the apps figure out which car is sending the data. So then you can make sure that you record it against the right car and you exchange data with the right mobile app for the owner of the car. And the firmware version is useful as well, because it makes sure then if the car is running an older version of firmware, you don't want to start popping up buttons and options on the mobile app that the car doesn't support. So knowing the firmware version helps you with that. And once again, it makes it very easy to encapsulate and carry this sort of information in your MQTT messages with user properties. You can also do some things with apps in MQTT 5.0 that you just couldn't do in MQTT 3.1. And one of my favorites is message expiry. And with message expiry, when you publish an MQTT message, you can include a field in the message that says how long this message lives for. So if I've got my mobile app and I press the honk horn button, but it can't be delivered because the car doesn't have a mobile connection at that point in time. It's just parked in a spot where it's not getting good connectivity. You don't want to then jump in the car and be driving down the road and have the horn spontaneously go off when the car's mobile connection finally gets restored. So the honk horn message might have, a 10-second or a 20-second message expiry, so that if the message doesn't get to the car in that period of time, then the broker just deletes the message rather than delivering the message later on. So you do a lot of cool things with message expiry. Request reply is also a very powerful capability that was one of those things that you had to handcraft as a developer and leap through some hoops to do with MQTT 3.1. So remember the previous slide where we had the security alert going to the mobile app with a picture from the car? the car owner might then send a request saying, oh, that's interesting, but that picture's kind of blurry, take a new picture. And that message goes down to the car sends the reply back. The owner looks at the photo that comes back as a reply and see, oh wait, it's my buddy that was going to meet me beside my car standing in there on the rain. So from the mobile app again, I'll push the unlock doors. Car does that and replies with a doors unlocked message back to the mobile app. So it's a very powerful paradigm, especially when you're trying to control things remotely. And it's a very nice thing to have built into the protocol. Now, just in case you're off coding an application, in practice, the mobile app won't be sending the message directly to the cars. We've never seen it implemented that way. What happens is the mobile app will actually send the request to a server-side application. The application will then send a request to the car will send the reply back, and then the server-side app will send the reply back to the mobile app. But still, it's request reply that's making all of this happen. On the server side, one of the big challenges with MQTT 3.1.1 was how to scale out the microservices. So if you think of the connected car application, you're going to have millions of cars, and that's going to be way more than what you can do with a single instance of a microservice. So you need some way of load balancing messages from the vehicles and from the mobile apps as well, actually, across all the instances of the microservice. And that's something that was added in MQTT 5 with shared subscriptions. And so you can have 1 or 10 or 100 instances of the microservice all subscribing to the same shared subscription. And then the event broker will load balance messages from the cars, messages from the mobile apps across all those instances of the microservice. That means you can start your infrastructure small with maybe a few instances of the microservice. And as you add more cars and you need more processing capacity in the back end, you can add more instances of the microservice, and then the messages just continue to be load balanced across all those instances. So it's a very powerful capability. It's supported for both the QoS 0, the non-persistent, as well as the QoS 1 persistent subscriptions. It's something that actually Solace brokers, we support for QoS 0 in both MQTT 3 as well as MQTT 5. The QoS 1 support for shared subscriptions on the Solace brokers, that'll be coming in the second half of 2021. So it's a feature that we're developing now as an add-on feature to our MQTT 5 support in the brokers. In addition to the features that MQTT 5 adds that makes it easier to build apps for your devices and makes it easier to build your server-side application, there are also a couple of features that make it easier to manage the event brokers themselves. The first of those is session expiry. So if you think about persistent messaging, where you publish a message and it gets queued in the broker until it can be delivered to the cars. And if you're publishing messages that don't have a message expiry, then that message sits in the broker until it can be delivered. And when you're talking about millions of cars get sold, they get scrapped, they get shipped to other locations. There can be stale messages stuck in the brokers that haven't, and the cars haven't connected for days or weeks. They haven't connected to the mesh. So once again, if you're a large car manufacturer, this can be very expensive and very tedious to have to go in and clean up this state for cars that you haven't heard from in a long, long time. So session expiry lets the brokers just clean up those resources automatically. So you can basically say that, even though I'm using persistent messaging, if this car doesn't connect, in 2 weeks or in a month, just delete all its state, right? So you won't have to have an administrator go in and clean up after it, because a message that is a month old probably isn't relevant to anyone anymore. So you can do this cleanup automatically. The other thing that MQTT 5 adds is the ability to scale out your event broker infrastructure, right? So if you've got millions of cars, it's going to mean, at least dozens of event brokers connected together in an event mesh to handle all those connections, right? And you really don't want to then be going and saying, oh, this car will connect to broker number 1 and this car will connect to broker number 2. Hard coding it just it's not a good idea, right? It doesn't allow the network operator to grow the network and add more brokers. It doesn't make it easy to rebalance and decide which broker a car is going to be connected to. So server reference is a feature that's been added to MQTT 5 to address that, right? So with server reference, you can hard code in all the cars, connect to this DNS name, connect to this IP address, right? It'll connect, and then that might be, that might be through a load balancer that randomly connects to any broker in the mesh, and that broker will say, "Oh, it's Steve's car. Steve, you aren't connected to broker number 8. Redirect your connection to broker number 8." And that all happens with the MQTT protocol and the MQTT APIs. The app doesn't have to worry about this at all. So it makes it very simple for your apps. One connect string, one connect address for all the cars, and let the brokers figure it out. So this is a feature that isn't available yet in the PubSub Plus broker. It's another feature that we are planning to deliver in the second half of this calendar year. MQTT 5 also has a couple features that help you write portable applications. The first is server capabilities announcement, where the broker will tell the applications what features it does support and what features it doesn't support. And that way your apps can dynamically adjust and not try to take advantage of features that might not be supported by certain brokers or certain versions of the broker. On the other way around, your devices, your cars can also tell the broker what it's expecting, right? So things like receive maximum, like the maximum number of messages it wants to receive in a burst, and what's the biggest size of any packet, right? So it's important because the car might have limited resources and you don't want the broker overwhelming the car. But next year's model year might have a new computer with more RAM and more capabilities. So next year's car might advertise a bigger max packet size or a bigger receive maximum to optimize communications with that car. And so it's a very powerful capability for the car to tell the broker and the devices to tell the broker what they are capable of accepting. Perhaps one of the biggest challenges with MQTT 3.1.1 was for developers to figure out what was happening when they sent a message to the broker that the broker couldn't parse. Because in 3.1.1, what the protocol said was, if you don't understand the message, disconnect the app. And that doesn't give a developer a lot of clues as to what's going on. So with 5.0, one of I think the best things they've added is the ability for the broker to reply with Reson Codes to tell the developer what went wrong, or at least give the developer hints as to what went wrong. Now, maybe not so important when you're building the device side where you get your app working once and then you burn it into firmware and you never touch that app again. But on the server side, where you're doing a lot of innovation and unrolling new apps and you want to use MQTT 5, well, really helpful there that when things aren't working, that you can at least give the app programmer some hints as to what's going on, right? And you don't have to go back to the broker and look at debug logs and event logs in the broker, and hopefully it'll give you the clues as to why the app got disconnected. So you got a CI/CD pipeline where you're building server-side apps. Having these disconnect reasons, I think, will be really helpful to the developer teams. Well, that brings us to the end of our whirlwind tour of MQTT version 5. As I hope you've seen from the slides, it still remains as a very clean, lightweight, interoperable protocol. It's got a rich ecosystem, really makes it a great choice for any IoT devices that you're building. And as well, it's easier to build your apps now, and it's got a lot of capabilities that allow you to build server-side apps and mobile apps that weren't there in MQTT 3.1.1. And as an added bonus, in the Solace brokers, you don't have to stick strictly with MQTT 5. It's interoperable with all the other APIs and all the other protocols that you want to use. So MQTT 5, it's available as a beta right now in PubSub Plus event brokers, and it'll be GA very, very soon. So thank you for joining us for this presentation. I hope you found it helpful. Be very interested in hearing your feedback. Thanks, and have a great day.